Okay, good morning, everyone, and welcome to CE3372 Water Systems Design. Today's topic is green infrastructure. So this is just be an introduction to some concepts in that, and then we're going to take a tour of some, I hope I can find my examples in SWMM of the different components from a modeling perspective. But first, I think my cat has got to settle in, decide where he's going to be in the way. And see, you don't want to take an exam, so let me go ahead and delete that. And this is our class, and I don't think I have the links put up yet, so let me just put a quick one up so that you can get to it if you want to. '24, weird. I bet I don't even have it on the content server yet. Okay, that's correct. Now, where is lesson 24? It's been one of those days. Okay, that's the right lesson. Let's get it pushed onto the content server real quick. So that's here, water systems design lessons. It's not there yet. All right. Apologize and bear with me. This won't take that long.
Yes.
I'll be going without an index file for the time being. Actually, I guess I can grab those. Those are pretty quick. Failed once. Of course, it's a security update. That will guarantee nothing works. 800K, is that the right size? 800K, okay, cool. The copies are there. And we'll make a quick change in the index file, and then we will get on with class. So you're getting free web programming right now. This is
Could you share your screen?
okay, none of those work. Green infrastructure, and this lesson introduces all right, cool. Now the readings are all wrong, but I'm not going to worry about those. Okay, so in theory, if we go here and we actually had content folder. That's not right. Lesson 24, green infrastructure. I thought I had this done already, but apparently not. Lesson folder exists. Now we go inside and we put some content into it. Almost there, everybody. Done. Okay, so I should be able to close this. Close that. We will test everything. Let me mute everybody because I'm getting a lot of noise. Mute all. You've all been mutated. Hopefully it didn't hurt too much. Okay, so looks like I've recorded all that. I'm not even going to edit it, so there'll be a bunch at the front. All right, again, welcome to ce3372. Today's topic is lesson 24, and the title is Green Infrastructure. And we will go take a look at that. See if it downloads and opens. Sweet. So green infrastructure. So this is the first semester I've ever been able to get this topic inserted into the class. So that's a good thing. But it's also, because it's the first, it's going to be a little bit rough around the edges. I guess the rest is rough too. So what is green infrastructure? On the screen are the definitions from the EPA, and I'll just read it to you. Section 502 of the Clean Water Act defines green infrastructure as, quote, the range of measures that use plant or soil systems, permeable pavement or other permeable surfaces or substrates, stormwater harvest and reuse, or landscaping. Now here's where the highlight matters. Those other yellow parts are a mistake. Or landscaping to store, infiltrate, or evapotranspirate stormwater, and reduce flows to sewer systems or surface waters. So green infrastructure are measures whose purpose in life is to take the runoff that's generated in a drainage area and remove that water from the runoff stream by either storing it, soaking it back into the ground, or increasing evapotranspiration rate so that the water doesn't get to the sewer system in the first place. Its purpose, in contrast to conventional stormwater infrastructure, which is comprised of piped drainage and water treatment systems, which we've talked about pretty much throughout the course so far. Conventional systems are designed to move stormwater away from the built environment and take it to an outfall. Green infrastructure, its purpose is to reduce and treat the stormwater at its source, and then the marketing part, while delivering environmental, social, and economic benefits. So the components of green infrastructure, we'll list these individually and then discuss them a little bit. I have some photographs. So in the green infrastructure, one of the components is downspout disconnection. And so there's a picture here of a downspout from a building, and it's pouring into this landscape box and then moves on about its merry way. Rainwater harvesting, and that's not catching Dr. Rainwater and removing a marketable organ. He wouldn't like that. But actually collecting rainwater with the intent of using it for irrigation water later on. In fact, all of our water supply as human beings is some kind of rainwater harvesting, even if it's groundwater, because the ground is harvesting rainwater for us. But this really refers to a much smaller scale of that. Catching it in cisterns or large barrels and then redistributing it. The other component is called a rain garden and a planter box, which is a type of rain garden. A bioswale is a fancy technical sounding word for taking a ditch and putting plants in it and then having them do plant things. Permeable pavements, here's a photograph of one in the upper right. So these are called permeable paver blocks, and they're designed to have very high permeability. Not like you've had in concrete class. This is very porous, cementatiously bound material, and they're expensive because the aggregate portion has to be really well washed to get the sizes correct for it to perform its task. And this particular one looks like it's laid on top of a grid. And what happens is water will come onto this permeable pavement and soak straight into the substrate. And you get really high infiltration rates. So literally up here where it's ordinary friction course, there could be ponding, and as soon as the water gets here, the pond completely disappears. And those are the general category of permeable pavements. And then there's something called green streets and alleys, which is just an ordinary street, but you go out with a paint truck and you spray paint everything green. Just kidding. These are streets and alleys where unused portion for traffic is perhaps landscaped, just like this picture here. And then there's green parking, which is just like the orange parking, but it's the other parking lot. Now, again, it's an ordinary parking lot, possibly with pavers like this photo, and then vegetated areas between parking rows. Green roofs, here's a picture of a mostly green roof with a little bit of brown and red thrown in to render some visual contrast. A green roof is taking an existing roof or a new roof, reinforcing it structurally so that we can grow things on top of it. And the main purpose for these is to confer water quality benefit on the water as it runs down the downspout on its merry way, urban tree canopies, and land conservation. So all this stuff is decidedly an Eastern United States naming convention, because they had to sell this to people. So they put the word green in front of everything that good development engineers and good landscape engineers do anyway. And that is the pieces of green infrastructure. If you go to older literature, it will be called either best management practices or low impact development. So LID, BMPs, GI are all catch-all terms for the same engineering features. And what is the point? So this next is green infrastructure and urban stormwater impacts. So first, development, urban development. We produce large areas of impervious cover. And those large areas of impervious cover and the associated changes in land use, going from undeveloped land to houses and choo-choo trains and apartment buildings, increase the volume and rate of stormwater discharge. They increase the rate because they change the hydrologic timing. They increase the volume because the impervious cover replaces areas that used to absorb rainwater as it fell. The ultimate impact of this development is increased pollutant delivery. Water that used to soak in the ground now makes its way to other places. Increased flooding and erosion. The flooding is somewhat self-evident because of the increased volume. The erosion, not so much self-evident, but because we increase the rate of stormwater discharge, we tend to increase velocities, and when that gets to erodible materials, the increased velocity is increased shear stress, which easily destroys the material, and decreased recharge to groundwater. At a small scale, at a neighborhood or a parking lot, the pollutant delivery is measurable. Increased flooding is probably measurable. Erosion, maybe. Decreased groundwater recharge is not measurable at that scale. But when we scale it up to the size of a municipality, an entire city, something like Lubbock, the groundwater recharge decrease at that point is quantifiable. So with groundwater, we have to have enough surface area to really be able to measure anything. It's surely happening at the small scale. It's just unmeasurable. It's one of those cases where things that we think are zero, if we add enough of them together, pretty soon it's real money. So how are these components implemented? The actual design of the individual components is pretty straightforward. Designing a planter box and putting soil and the proper plants in it, and designing the substrate to take care of the infiltration, that's largely hydraulic engineering, and you all know how to do that already. But predicting the performance is a different story. So because engineering is a business, if we are going to implement these or are required to, the people paying for it want to know how it's going to work. I mean, why should I pay for a fancy planter box with little fruit trees in it? How's it going to benefit me? And so we predict performance in a variety of ways, about 3 of them. One of them is to look at existing reports and databases and make a flat out guess. An informed guess, because it's informed by the reports and databases, but it's still just a guess. A second way to predict or estimate future performance would be to use some screening tools. These tend to be large-scale estimations. We'll go take a glance at one. And then the third way is through modeling. And that's pretty much the leading approach to estimate performance of a network of green infrastructure components if you're going to implement them in a particular project in order to demonstrate that with these additional components to an otherwise ordinary conventional sewer system, we obtain benefit. And we'll look at a few of the components that are implemented in SWM just to teach ourselves of their existence. So reports, here's a set of reports. There's 2 screens of these. And they're kind of dated. This stuff's looking from the 2005, so we're at least 15 years old, but I am quite confident in stating that this has been ongoing since these ones were published. And so the listing of reports is probably quite long. And I will maybe go to one of these, but we have to want to see one that it's likely that we'll actually get some information. Well, first we can look at National Academies. This one probably is an active link. And so this is a study in Illinois, and examining discharge changes over time. And this won't have green infrastructure, but it will demonstrate the effect of urbanization. So if we look at these 2 hydrographs, we can think of this first one is prior to urbanization, and the second one is after urbanization. So from that report, we could make a guess as to what impact we have on this green curve if we reduce some of the urban infrastructure components by using green infrastructure techniques. Another suggestion might be to look at the national academies, but let's get away from this before it finds a way to sneak $75 out of our pocket. And I had one that I knew we could get to. Let's see. That's going to hit a paywall or not. Okay, so here's an actual report that we can look at, and it discusses responses and has a rather simple influence diagram. Just kidding. When we get to conclusions, let's see if it gives us any guidance on how to implement these. Naturally, nothing. So circa 2005, this was the level of knowledge. Low impact design is an approach with great potential, but there's not enough information to assess its impact, and hence, since it has to be paid for, until that information is available, it won't happen. Kind of a sad situation, but understandable. See, Journal of Hydrology will paywall, and the previous one, that's not going to, oh, this is a good one. Hopefully we don't get paywall. That's a Pew Trust. So this is a report that shows the effects of urbanization, and then strategies and tools for protection. So that's one way to try to estimate how anything we design might work from a marketing standpoint. Our next would be to look at databases. So we'll look at this first one called the International Stormwater BMP Database. And this database has a interesting history. Has a way to add data to the database, get data from the database. And let's go with the history of the database. It was begun in '96 with ASCE and US EPA, and over time, its funding has changed from Water Environment Federation, Federal Highway, American Public Works, EWRI, and so this has been a really good program for a lot of years, initially funded by the EPA. And there's a lot of publications that have come out of this database. So parameters, and in the actual database, see what this one does, if we actually hit a paywall or not, are some, yeah, that one's a ASC, that's paywalled. And some of the links are obviously dead, which is not surprising. Let's see what the mapping tool does. I'm trying to avoid actually downloading the entire database. It's not that big, but I don't want to clutter up my computer. Okay, so this tool shows where data exists, and I'm zooming in on Houston because I believe the detention pond that I have you using for homework it's not in the mitigation bank. Their map server is terrible. And here's a typical database summary. So it has the physical dimensions of the particular BMP, which would be useful for design. So if you're designing something, you have an idea of the physical dimensions, and then there should be a link to the actual performance data. But they've not critiquing them so much as I'm not familiar with there it is, flow and precip summary. And you can pick a particular data, a metric, and then use that to estimate performance of that particular BMP. So this is a tool that could be used to support design. Another one quite similar is the National Pollutant Removal Database. Let's see if that link is working. From Center for Watershed Protection, and then it has a report listing, and then somewhere is the actual database. Oh, this is simply a summary report. So we'll do a little bit of web searching and see if we can actually get to the database. Let's see what that does. So somewhere the actual database is available, but I can't find it right now. So that's another set of tools that we have. We can look at screening tools. So there's the National Stormwater Calculator. So this estimates rainwater and frequency of runoff using green infrastructures as low impact development control. So this is not a bad starting point. There's a web-based version. There's a computer version. The only limitation of this is that a network connection has to be available to use it, and it's strictly Windows-based because it's using the .NET framework. We click on access the mobile app, So we're doing this over the wire right now. And then we name our site. And it can't find our site, but let's see if we can click on a spot. Use this polygon, and then you can build your project in the actual application. Do nice 6 acres. Okay, so we've done that, and then you've got to work your way through the tool. So that's another tool. There's also a similar calculator. This one is called the National Stormwater Management Calculator. This, I think, is a little bit easier to use than the other one. They're quite related. I think they have the same computation engine in the background. So we select different tools. We describe our lot. We describe pre-development conditions, runoff reduction goal, conventional development, green improvements, advanced options, run it, and it will estimate various volume control and pollutant control. So these are good tools, and this would certainly be, in my opinion, a starting place for impact design. The next tool would be, if we need to get down to the details, we would kind of be restricted to having to use modeling tools. And in SWM, which is the model that we've been using this class, it has explicitly the following components built into it somewhere: rain gardens, bioretention cells, vegetative swales, infiltration trenches, green roofs, downspout disconnection, rain barrels, and continuous pavement systems. Now, all these could be simulated more or less with ordinary SWM without any special treatments, but they added these to make it easier for the designer to assess their design. And so we're going to go to the Share SWM, and I have a database in there already called NSIM database. And with any luck, we'll be able to learn a little bit about the SWM capabilities with green infrastructure. So now I have to find my way to those locations. That's in Blackboard, and go to the home page. BNC2. I hope this is running. It probably broke on Tuesday also. I haven't checked, so I don't know. Well, that seems pretty good so far. VNC pound TWO. And I have just a few here. Let's see if there's any infiltration tent. Wonder if this can even open that. I have it as a PDF. That's what I wanted to look at. So this is just one of a handful that are available. And assuming it will open the PDF in our lifetime. Well, that's deciding to load or not load. Go ahead and launch SWM 51014, and let's see what I'll launch the interface. And so the toolkit is in lid controls. So I'm trying to find one of the lid controls that's built in so we can look at the interface. So they did a nice job on, there we go. Lid controls. And it's not rendering. No surprise there. Open with Chrome. Okay, so here's an example of one of those type of lid controls. So want to substitute an infiltration basin for bioretention, and then it shows you a sketch and has instructions on how to build it. So keeping that in mind, let's shrink that and we'll go ahead and load in this actual example. File, open, hopefully I can find it. Desktop. Just going to guess on one of them, see what we get. Could not find the backdrop file. So here's a backdrop file. We have some porous pavement. You can see the parking bays here and a bioretention cell, and then all this drains into the bioretention cell and goes on out. Let's turn off the backdrop. And there's our swim model, not very elaborate. Let's take a look at what we have here. We have a subcatchment that is 0.29 acres, 42 feet wide, 2% slope. That's actually pretty steep. Let's see if there's any other objects hidden up there. None? Okay. And then that connects to a subcatchment infill, which I believe is that's just a name. It takes a rain gauge to a junction and on outward. And that drains to a junction, drain pipe, outfall. So this is in this area is 0.034 acres. So this is just a hydraulic model. Let's see if there's any lid controls in here. There is. There's called lot treatment. And the control name is lot treatment. The control type is an infiltration trench. And the other types are here bioretention, rain garden, green roof, trench, permeable pavement, rain barrel, rooftop disconnection, vegetative swale. And for each of the different types of lid, we have to provide some physical dimensioning of the object, its storage capability, and then how it's going to drain. And these are described in the user manual. We have help available if we want, but as we can see, it's not not rendering correctly. That's kind of frustrating because it's worked good in the past. Well, if you have a truly Windows-based representation, those will probably load. And then we go ahead and run our simulation. We can look at the outlet and let's see what there is to see. We have just the hydraulic variables. No lateral inflow. So there's the pipe flow from our cell. Let's go ahead and take a look at what the outflow from the subcatchment look like, because that's what's been treated. So our subcatchment peaks at 1.4, but it has a duration of a couple hours. And here what we've done is by storage, we're storing that and letting it off pretty quickly and then mitigating it. And there's no quality information in this example. So implementing the lid components takes a little bit of ingenuity in that the online user manual isn't very helpful right now. But there are a few other examples. Let's see what else is there. That's all code. See if I have better slides. Okay, open that. What is that, a PDF? Yeah. So these are all the examples we have files for. So you all know how to do this already. I'm trying to get to a lid example. There we go. So in doing these green infrastructure examples, we have to identify the impervious, the pervious, and then the various components that we're going to implement. And the lid control editor, which we've briefly just seen, is used to define a green infrastructure control that can be deployed throughout a study area to store, infiltrate, and evaporate subcatchment runoff. So the lid control editor operates on catchment objects. The design of the control is made on a per unit area basis so it can be placed in any number of subcatchments of different sizes or number of replicates. The editor contains the following data entry feeds. The control name, that's just a name. The generic type of control, bioretention, rain garden, green roof, infiltration trench, permeable pavement, rain barrel, or vegetative swale. And then the processes that are going to be implemented. In the process layer, there's a surface layer, a permeable layer, a soil layer, storage level, drainage system, and then some meteorological information. So here's a, wish I could find that file, session 24, units.inp. Let's see if we can find that file and load it. Session 24. Nothing there. All right, there is a session 23. You would think 24 would come after 23, but it's missing. I've been working on writing these up, and I obviously haven't gotten very far. Yep, I definitely don't have session 24. That is bizarre. Well, let's go back to the session 30 has LID. See if we got a session 30. One of the challenges of all these input files is they had to be sanitized so that they couldn't identify the locations in the world where they are. Looking for session 30. All right, so there is a session 30. Let's go ahead and try to load it. I just want to look at the lid editor so we can look at some other examples. So I want to open, choose 9. So I don't have a backdrop, so I don't really know the orientation, but we have these various subcatchments. So this one's called pavement, biocell, green roofs. Okay, so this is a fabricated example. Rain gardens, trench, swale, and cistern. So the 7 different types of lid controls are represented in these 7 different areas, drawn in arbitrary shape, and then they're all coming through conduits to a common point, and then to an outfall. And so this allows us to examine the effect of these different tools on impacting runoff. So let's start with one that is somewhat simple. Pavement. So pavement has an area of 1 acre, width is 162. I'm sure this is in feet. Yes, in feet. Let's look at cistern. I bet you they're all the same setup. So again, every single one of these areas is functionally the same. Same area, same width, same percent slope. And so the difference other than the names is going to be the lid controls associated with them. So we're first looking at pavement. So here's our lid control editor, and we have pavement. There's a soil and a storage portion, and then the ability of it to soak into groundwater and the ability of it to drain out in some other drainage route. On the surface, we tell it how thick it is, the vegetation volume, the surface roughness, and the surface slope. So in this case, the surface slope is 1%. Then the pavement itself, we state how thick it is. The soil, its properties. The storage, its properties. So 2 inches of storage, void ratio of 0.75 means that you have about 1.4 inches of watershed storage available in the storage section. Its seepage rate, which is this arrow here, and then a clogging factor. And finally, the drain, a set of drain coefficients. And we can choose the drain advisor, which doesn't work on this particular implementation. And there's similar inputs for example, the biocell. We can look at the biocell control. Different picture with pretty plants. It has a berm height. Think of that as a ponding depth. And once it goes beyond that, then everything flows untreated. Has a soil fraction, storage component, a drainage component. There we go, drainage component. Our rain gauge. Usual, it's an SCS type 2 storm in this particular example. And if we run our simulation, our run is unsuccessful. Cannot open report file. That's not very useful. The usage section. Wonder if it's let's look at the input file, because that's probably why I don't have a correct example yet. The giveaway was trying to send that to drive D. Currently, nothing wants to work. Send the instruction again. Weird. I don't know why it's trying to write to drive D right now. Okay, C users, blah, 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 master file input. Cannot open the report file, line 30. Ah, so it's looking for data. I guess let me run that again real quick. So we're getting a little bit of SWM debugging. Error 305, report file line 130, lid usage section, D. Ah, there's a bunch of files that are missing. That's why none of these things work right in the short course. Biocell. .txt. Well, I will punt on this. This particular one is looking for a text file called biocellretention.txt. And let's see if we can find where it's supposed to be. Control name. So it's not looking for a file there. Not there. So they're the interface files that are missing. Okay, I can't show the example. That's very frustrating. Sorry about that. With that, I'll return to the modeling components. So we've at least seen where the modeling component entry locations are. And that particular example I was trying to show is somewhat advanced because it uses interface files. And so these are all similarly treated, and a little bit of a reading of the SWM user manual would allow one to implement these various components. Keeping in mind the components are applied on the subcatchment objects. So they're not individual little widgets inside a SWM model, although you could model most of these as individual little widgets inside a SWM model as hydraulic elements. And that's an alternative. So that pretty much concludes my rather clumsy lecture on green infrastructure. And I guess I'm not too upset since this is a first attempt at introducing these concepts into this class. You will encounter the terminology in your engineering career if you end up working in drainage engineering, because there's increased emphasis on water quality aspects of stormwater management, and to some extent, this impacts sanitary sewer systems. So other than being an introduction, that's about as far as we can get today. And I'm going to actually disconnect from this. Not so much to hide my mistakes, although that's certainly a motivation, but to go back and repair on it later. And try to get back. There we go. Let me check the chat. I'll answer the chat question. Let's see. Going off email on Tuesday about the remaining grades less. We're going to have one report for the course, no presentation. That's correct. We're going to combine the project report into both the drinking water system design and the storm drain design for somewhere USA. We're not going to do a presentation. I would say something trite like, well, if you want to, you could upload to YouTube. We're just not going to do it. And that is the remaining materials. So there's 2 homework assignments, a 3rd exam, which will be during whatever the normal final exam for this course is, but it'll be online. And if there's files, I will put effort into being sure it's pointing you to the correct file so that you have a better shot at getting your answers. And the report. If there's no further questions, I think I will cut today's class a little short. And wish you all a good weekend, and use the weekend to work on those 2 homework assignments. Next Tuesday, I will have a template of what you need to put into this project report, mostly so that you don't go running amok and spinning your wheels. Just a kind of a layout or a format of what needs to go in it, so that you can convey the information that you've created without having to do too much. Oh, I've got to move these off. Problem with private message when I'm doing full screen sharing is if I'm not paying attention, the whole world sees it. We'll pick up next time on project report. So with that, I want to wish you all a great day, and I apologize for the somewhat confusing lesson today. I've been working on these examples for quite a while, and I thought they were built, and I guess they're not yet. Will there be class Tuesday? Yes, the Tuesday class will be the report format, and we can use that as a workshop if you have SWM questions, or I suppose EPA net questions in the context of the design report. Any other questions? All right, well, very good. Thank you for your attention, and I will get this video uploaded as soon as I can. Not much of a video today, but it's the best we got. And have a great weekend. So long.